Alright, Chem students, today we're going to talk about radioactive decay. You need your notes packets, your periodic table, and something to write with. Okay, so many isotopes are radioactive. This means they undergo radioactive decay. They naturally break down into a smaller element and release particles and energy in the process. Now, the reason that they break down is that their nucleus is unstable, and that's due to an unfavorable neutron to proton ratio. They will decay to form a new element with a more stable neutron to proton ratio. Now, the first way this happens is called alpha decay. An unstable element will release an alpha particle, and that's the little symbol there, which is essentially a helium nucleus. So that's how we will show it in our equations. Helium has a mass number of 4, meaning there's 4 total protons and neutrons, and its atomic number is 2. So that right there is an alpha particle. For example, we have uranium, mass number of 238, atomic number of 92. It is going to decay into thorium, which has a mass number of 234 and an atomic number of 90, plus our alpha particle. The two things here actually add up to 238, just like how uranium started. And the bottom two things also add up to 92. So this is a good way for us to check ourselves. If we're missing either one of these, we can figure out, okay, if uranium decays to thorium, it had to be releasing an alpha particle. Or if we know that uranium releases an alpha particle, we can backtrack and figure out that the new element would be thorium. And that is because these two numbers here have to match the other two. Okay, our second type of decay is beta decay. That is what happens when a neutron in the original atom decays to form a proton and an electron. We call that electron a beta particle, and its symbol looks like that. Now, the neutron is represented in the original element. The proton is represented in the new element. So you will see a switch from one side of your equation to the other. For example, we have lead. Lead has a mass number of 210 and an atomic number of 82. But when it undergoes beta decay, it becomes bismuth. Still has a mass number of 210 because nothing changed overall for the mass number. A neutron became a proton, but that didn't affect the overall total mass number. But down below, our atomic number did go up 1. And as a result, the -1 from the beta particle cancels that out. So they will still add up to 82 to match what we started with. Now, this again is a great way to check ourselves. Mass number is 210 on this side, it's 210 on this side, 82 on this side, 83 plus -1 is 82 on that side. Now, both kinds of decay, both alpha and beta, will also release gamma radiation in the process. Gamma radiation is pure energy, not a particle, so it is not represented in any of our equations. Now, to give you a little more information on these particles and energy. Alpha particles, which are our helium nucleus, are much more massive. They have a mass number of 4. There's substance there. They will actually cause the most damage over a short range, but they are least able to penetrate surfaces. They can be stopped by a piece of paper. Beta particles are less massive because they essentially only consist of an electron. They cause less damage over a short range, but they are more able to penetrate surfaces. They can be stopped by a thin sheet of aluminum foil, but they would be able to penetrate your skin. Now, gamma has no mass. It's all energy, and it would cause the least damage over a short range. But it is the most able to penetrate surfaces. It can only be stopped by a thick sheet of lead. Now, essentially, we have a diagram here. This is what plutonium would give off: alpha, beta, and gamma radiation. So the alpha radiation could be stopped by the piece of paper. The alpha and beta radiation could be stopped by the foil, and the lead was the only thing that would be able to stop all three. So this top one was alpha, The second one was beta. Third one was gamma. Alright, that's it for today's lesson, Chem students. Make sure you do the appropriate pages in your practice packet, and we'll see you for the next video.